This video is on solid revolution. So this graph right here, I have the function f of x equal to cosine of x plus x. And then this line right here, this is the function g of x equal to x minus 3. And we have this region right here, and I would like to rotate this region right here about the line y equal to x minus 3. So this is the axis of revolution. And so to find the volume of the solid of revolution, what I'm going to do is I'm going to take this region right here first. I'm going to shift it 3 units to the left so that the axis of revolution would go through the origin. And then I'm going to rotate it 45 degrees, and then we end up with a solid of revolution that looks like this. And then we can find the volume of this solid of revolution. So here's our region again. And so the first thing I'm going to do is I'm going to shift this region right here 3 units to the left. And so to shift the graph here 3 units to the left, we just replace x with x plus 3, and then x plus 3. And then same thing for here, replacing x with x plus 3, then we end up with just x. And so the function for this graph here will be cosine of x plus 3 plus x plus 3. And then this line right here would be just the function g of x equal to x. And then notice that because this is the line y equal to x, the new axis of revolution right here, so this angle right here, this angle theta, be just 45 degrees. And so I'm going to take this yellow region right here, I'm going to rotate it 45 degrees. And we would end up with this region like this. And now let's talk about the boundaries. This is the original graph right here. And so originally the graph, this graph right here, the graph cosine of x plus x, it goes from x equal to 0 to x equal to 2 pi. And now let's find the parametric equations for this graph right here, and then we can find the volume of the solid revolution. So originally the graph, this graph right here is y equal to cosine x plus x. And so the corresponding parametric equations are x of t equal to t, y of t equal to cosine of t plus t. So this set of parametric equations is for this graph. And so at this point right here, this is when x is 0, and then at this point x is 2 pi. And therefore at this point t will be 0, and then at this point t will be 2 pi. And then what we did next was I shifted the graph 3 units to the left. And so the equation, the rectangular equation for this graph right here would be y equal to cosine of x plus 3 plus x plus 3. And for this equation right here, the parametric equations are x of t equal to t and y of t equal to cosine of t plus 3 plus t plus 3. But because we shifted the original graph 3 units to the left, so t will go from negative 3 to 2 pi minus 3. Originally it was from t equal to 0 to t equal to 2 pi. And so for this graph, to get this graph, we have to go from t equal to negative 3 to t equal to 2 pi minus 3. And then next we rotated this graph right here, rotated it 45 degrees to get this graph. And so so from this graph to this graph, we would use these rotation formulas right here. And so the parametric equations for this graph is going to be x rotated, it's going to be x cosine theta minus y sine of theta. And then y rotated will be x sine of theta plus y cosine of theta. Once again, this x and this y, they are points on this graph, not on the original, since we're rotating this graph. Theta here, to rotate this graph right here, the theta, this angle right here is 45 degrees. And so cosine of 45 degrees is square root of 2 over 2. And then here we get to the square root of 2 over 2. And then x is just t, and then y is the cosine of t plus 3 plus t plus 3. And then the same thing for y rotated is going to be x, which is t. And then here we get square root of 2 over 2. And then the y is going to be cosine of t plus 3 plus t plus 3. And then cosine of theta be just square root of 2 over 2. And so these right here, this set of parametric equations is for this graph. And then simplify, we get x rotated to be negative square root of 2 over 2 times cosine of t plus 3 plus t. Because right here we get t minus t, which is 0. And then for this expression right here, we can rewrite it as the square root of 2 over 2 times cosine of t plus 3 plus 2t plus 3. So once again, this set of parametric equations right here is for this graph. And so once again, the original graph right here, the parametric equations are x equal to t, y equal to cosine of t plus t. And then this graph right here, the parametric equations are x equal to t, y equal to cosine of t plus 3 plus t plus 3. And then the rotated, this last graph right here, the parametric equations are x equal to negative square root of 2 over 2 cosine of t plus 3 plus 3. And then y rotated would be the square root of 2 over 2 cosine of t plus 3 plus 2t plus 3. And the original graph, t runs from 0 to 2 pi, and then we shifted it 3 units to the left, so t will be from negative 3 to 2 pi minus 3. And then this last graph right here is going to be the same thing, t equal to negative 3 to t equal to 2 pi minus 3. And now we're ready to find the volume of this solid of revolution. And this is what the solid of revolution looks like. And so this is the original region right here. We shifted it 3 units to the left and then rotated it 45 degrees. And then we end up with this solid of revolution. And so now let's find the volume of this solid of revolution. So once again, the parametric equations for this graph right here are these. And t will go from negative 3 to 2 pi minus 3. And volume for a curve that is revolved about the y-axis is going to be the integral with the expression x of t squared times the derivative of y of t times dt. Now if the curve is revolved about the x-axis, then it will be reversed right here. It will be y of t squared times x of the derivative of x of t. And so right here, x of t is going to be this expression right here, and then squared. And then the derivative of y of t, this is y of t right here, it's going to be the square root of 2 over 2. And the derivative cosine of t plus 3 is negative sine of t plus 3. And then derivative for 2t is 2. And then, of course, derivative for 3 will be 0. And then notice right here we have negative square root of 2 over 2 squared, which is 1/2. And then 1/2 times the square root of 2 over 2 is going to be the square root of 2 over 4. And then what's left is just this right here. And then if we evaluate this definite integral right here from negative 3 to 2 pi minus negative 3, then we'll end up with 38 pi. And then simplify, we'll end up with 19 square root of 2 dividing by 2 times pi squared. And so in the summary, the volume of the solid of revolution that we want is going to be 19 square root of 2 over 2 times pi squared. And that's the end of the video.